Hi guys. So welcome to this series of tutorials, and we will be building one app which is powered by LLMs, and we are going to have RAG components and some agentic workflow there. So in today's videos I want to cover a few Azure services that we'll be using for this tutorial for this business problem. We'll start with Azure Document Intelligence. Now what this service does is, as far as my use case goes, so I have this PDF. It's a court judgment. Now first what I want is to convert this to text. For that I'm going to use the Azure Document Intelligence service. The setup is very easy. I have this code in GitHub, and you set a virtual environment, and then using this requirements.txt install all the Python packages. Then I have this env file. So you will need to create a Azure Document Intelligence service, grab the URL, the endpoint, and then the API key. Instead, what I would suggest is, at least what I have done, is to create Azure AI services. So there are two of them. One is there is also like multi-account service key. I think it was the older way of doing that. So you have one URL, one API key for doing the document intelligence as well, for hitting the OpenAI endpoint as well. But with Azure AI services, so you will be able to have different endpoints for like your search service. No, the searches you still have to create, but for the document intelligence and then OpenAI, Azure OpenAI, you will have that at one place. You could create them separately, but I did try that, and for some reasons the PDF extraction into text I was only getting for 2 pages. But after I use this Azure AI services and the document intelligence endpoint and API key from there, I was able to extract the whole thing. And am I expecting any surprises for the billing? I don't know. I guess we will see. As far as the write-up goes, it's like pay as you go. It does not cost for deployment. When you do that, you will also have this Azure Foundry. So in that you will have to create this LLM as well as the embedding model inside that. I have used OpenAI GPT-4 GPT-4 Omni Mini, because that's the cheapest and it's more efficient than GPT 3.5, and the embedding model is the smaller one. So with those setup, I have this PDF, this code judgment being converted into text. I will not go through the whole code. This is all available in GitHub. The point of interest is just this one, this client, which is gets initialization from this endpoint, and it's coming from the environment variable that we set up in the env file, and the extraction happens right here. And after that, I have all the pages now, and then I can grab those lines, every line in that page. So I convert that into a txt file, and we are ready to go to the next step, which is creating index. So if you are coming from a vector DB background, like Chroma DB, um, you know, those vector DBs are fine for doing POC and then learning, but in the enterprise, I don't think people use that. People go for Azure search. There may be still companies who are using some Postgres as well for storing vectors, and maybe DynamoDB, and then maybe MongoDB as well. But trust me, in enterprise world, there are many companies, and at least the project that I am working on. So the client uses Azure Search, and it has indexing capabilities to store those vectors. So we are also going to use those, and it's the reason why companies do that, because to explain it to their customers, it's very hard to explain someone what ChromaDB is, but it's very easy to explain what Microsoft does. And if you are using Microsoft products, it has been built by like the best engineers out there, software engineers. It has been tested as well, so people trust it. An open source tool is like, now not criticizing open source. I use it a lot for my POC, but then when I'm building something for the enterprise, I have to use something that is tested. So the things that I need the indexing upon is the chunk ID, and then the parent doc, where the chunk came from, and then the chunk itself, and then the embedding. So these are the 4 fields that I need. And then of course I need the vector search, and by the way, you can so in this tutorial I am extracting the embedding and then uploading the document as well. I will show you that. But you could have some automation to have to create skills. Azure allows you to create skills as well in the search service. And what that will do is it will create the embedding for you. For that you also need a blob storage, create a container, and have a mechanism to upload the PDF there, and have the search service connected to that container so that the skill can run. So you would also need to have this communication from this search to that blob connection. So you would need to create roles as well, and you also need to have the connection with Azure OpenAI, because that's where your embedding model is. So I had really hard time figuring that out, and I think it's much easier to do that through Portal. But I was doing few things through Portal and then testing some code, and then code was in beta as well. I didn't have much luck. This is something I had luck with from one of the Azure POCs. I have isolated those components into separate files now. So the create index goes into here. I have done very minimalist modification, like what are the fields I need here, and that's all. And then I have this utility calling here in case I want to play with those index, and then I'm using create or update index because I may not be interested in deleting all the time. So I have little minor tweaks here, and once the index is created, so these are the index object, and then we call this API to create the index. We can go to the next step, is to create the documents from the documents, which is the one document only, the PDF, create those chunks. So here I'm using LangChain text splitter. Now I don't use LangChain for building agents, I use AutoGen, but I'm not like really looking for to write a splitter logic myself. I want to focus on more on agentic workflow side, and then play around with the splits. So I have this chunk size and the overlap. These are very small, by the way, and I will be playing around with them to refine my results as well. So I have these texts now, which are different sections from that PDF. So I look for this 4 fields that I need to go into that index, chunk ID, and then parent doc. So these are these 4 fields: chunk ID, parent doc, chunk, and the embedding itself. And then it's going to be a list, a Python list, and then we call this API. That's it. So now we have created the index, added documents, vectorized them as well to the index. This could all be automated using skills. Using if you have created a skill set here, and then run the indexer, it would actually pull that PDF from the blob storage and then run the embedding for you. And then I have search now. So what's going to happen is what I'm looking for is the winning arguments in that case. So the overall idea is what I'm looking for is to build something for a lawyer who has a case and he has certain situations in his case, and he's looking for winning arguments relevant for that situation. So based on previous court judgments where people have won their case, so what I'm thinking, if I can extract winning arguments from there, it could help that lawyer. So this is a legal research, case law research tool that I'm building. So this is my query, and then I run the single vector search query only. I'm not going to show like everything because the code's in the GitHub, and if you have worked with Python and you know about AI and have built something, I don't have to really go through that. I just as long as I tell you like how things work for me, I think that's going to be enough for you to for it to be useful for you. If you have any questions, put your comments. I will reply on that. So once we have this vector query, so this is how the API works, and it is different in the beta library. That's where I was facing the issues. So in those POCs, this vectorizer was also behaving differently, and what's happening here is I am able to call this model and then generate the embedding this way by passing the text here. Now these model this OpenAPI endpoint. So did I say I created these services using Azure AI services? In there you can go to this Foundry, Azure Foundry, and you can create the GPT model and then embedding model. So this is the small model that I was mentioning earlier that I'm using. So I get the top 3 results which I'm interested in, and the results are not that great actually. You see, this doesn't look like a winning argument. I mean, it's debatable. Like in a civil case, the preponderance of probability, the aforesaid plea was taken by, maybe there is something of some relevance, but the relevance score is very less. This is like the 60%. So assuming that the algorithm is using cosine similarity, this is very less actually. So what I need to do in the next step is to come up with a different query so that I can get better results. I want to see those results. I want to see those sections where there is a winning argument. Only if I have that information, those vector search results, then I can pass it to the LLM for summarization. So what I'm thinking is to have the agent generate the query for me. I can tell the agent that how a winning argument looks like. So when there is a query and then the results are there, just like we saw. So the agent will take that result and then give a feedback on that why it is not why it's not coming in relation to a good query and what the query should be. I'll have the LLM figure that out through agent, and then the query would change and then query the system again, and then keep doing it till I find some relevance, like the score increasing maybe till 80%. Right now it's 60, something like that. So I will have a query rewrite agent, and then query. So one generates the query, one gives the feedback, and then they communicate with each other. Then in the next phase, when I have found the query, I'm going to generate the relevant sections which contain those winning arguments, and then based on that I'm going to generate a summary, like the winning argument summary for that case. For that flow as well, I'm thinking I will use another agent to generate the summary, and there is another agent who gives the feedback on that, and based on that the summary can be changed. So there is going to be several agents here, and I'm going to use AutoGen for it. So I will see you in the next tutorial, and if you learned anything or two, put a thumbs up, and please subscribe. And if you have any questions, this all code will be available in GitHub. For any questions, post in the comments. This agentic AI is new, and one thing I must say is you just need to be software developer to pick up on these things, and you will not have that many questions. What's left for you would be uh, the LLM architecture. So I will make a separate video on that. And in fact, there are like tons of videos out there on transformer architecture. So mostly it just working with the agents. You have this LLM, and then how the agents will communicate with each other. How do you break down a big task into smaller tasks? Maybe going back first principles. That's the idea basically. Using agents, how you can automate several things. So I will see you next time, and I will tell you about what improvements that I have done and how I'm going to build this legal research tool. So until then, take care. Bye.